Good morning, dear friends. Today, I am presenting a very important topic to you people about sampling technique. Sampling technique is a vital thing while conducting any research. So, I will be guiding you about the what are the sampling techniques and how it can be done. So, starting the presentation. Dear friends, we will be talking about sampling techniques for decision making. It's a very vital thing for conducting a good research. The very first question which comes to our mind is what is sample? People often talk about sample, but what is the real meaning of sample? Does the sample means a small part of a larger body or is it something else? Let's see. A sample is some part of a larger body, specially selected to represent as a whole, that is, as a representative of the population. Let us understand it deeply using one example. The aim of a sample is to be representative of the population. This is the aim for a ideal sample. Now, what is sampling? Sampling is a technique with the help of which an individual or a study unit is being sampled out from a larger body to form a small subsample, which we are representing it as a sampling. So sampling is a process by which this person is chosen. Now, population. Look at the image. At the left-hand side, we have the global map. Here, you can see some Asian countries are there, some European countries are there, some African countries are there. It's a global map. And for this global map population, India can be one of the sample. Okay, so the population is the global and sample is India. Now, again, look at the smaller portion that is on the right hand side. Let's focus on India. India, if we look at it, can be a population, and if we are looking some states within India, they can be our sample. Now, suppose we have chosen a state called Uttar Pradesh. Uttar Pradesh can be our population, whereas different districts can be our sample. Similarly, if we have chosen a district called, say, Varanasi, Varanasi can be our population and different blocks within the district can be our sample. So we can see that every time a group of population, larger population, which we are taking, we are calling it as a population, and then a sub part, we are calling it as a sample. So from a layman term, if we talk about what is population and what is sample, here is a one-liner definition. A sample is a smaller part of a bigger population on which you want to study that smaller part, and based on that, you want to give the inference about a specific population. So, if we are talking about, say, blocks in Varanasi, they are a specific sample for the population Varanasi only. They are not the sample for the population Uttar Pradesh, but they are sample for Varanasi only. So before deciding on the sample, we have to be very, very clear that this sample constitute what population, so that how can we can generalize our results to the general population. Okay, so we cannot take a sample from Eastern UP and make inference about the Western UP. Okay, our population cannot be that. So whenever we are making an inference based on the Eastern UP sample, we would be drawing the inference that our study can be generalized for the Eastern UP population based on our sample. So be very careful before drawing the inference. Okay, do not make a vague statement that we have taken a small sample from UP and we are making inference about the UP. It is not possible unless and until you have taken different regions which compromises the state. Otherwise, defined the geographical regions from where the samples has been taken. So I hope the distinction between population and sample is clear. Now, we are talking about sample units. The individual member of the population whose characteristics are to be measured are called elementary units or elements of the population. So, the subject or the units which you are going to study or on which you are conducting an experiment are called your sample units. Here we have an example. If we are conducting a survey in a defined area to determine the proportion of children vaccinated against polio, the universe include all children living in the area, and each child living in that area is an elementary unit. Here, the study unit is children, because our objective is to study the vaccination coverage. Okay, so vaccination can be done for the children below 5 years. So elementary unit is children. Now we are coming on the two important definitions. One is population parameter. What is population parameter? Globally, no one is interested in a sample. Everyone is interested in population. Okay, so the population characteristics, we want to study the population characteristics based on a small sample. So the population characteristics are called your parameters. The parameters are basically the things which describes the distribution and appearance of the population when you graph them. Okay, the population characteristics can be average, can be standard deviation, can be its variance, can be anything. So population characteristics is called your parameter, whereas sample characteristics is called your statistics. So based on, with the help of statistics, we are making inference about the population parameter. Look at this example. Here, the population is there where we want to talk about the mean, average weighted birth. So average weighted birth for the population, average we are denoting it by mu, whereas for this population to study, we are studying a smaller sample, and the sample characteristics is denoted by the sample mean, which we have denoted here as X bar. So X bar is sample statistics, whereas mu is the parameter. Now coming on the sampling techniques. So basically there are two sampling techniques. Number one is probability sampling technique. Okay. So probability sample has the characteristics that every element in the population has a known probability of being included. Okay. So if you are selecting the study units in your sample such that every element which you are choosing has a known probability of being included in the sample, then the sampling process is called probability sampling. Whereas a non-probability sample is one based on sampling plan which does not incorporate probabilities into selection process. Often people get confused with probability sampling and random sampling. They say that random sampling is probability sampling. It's not like that. Okay, probability sampling means that you are knowing that the particular unit has a particular probability of being included in your sample. It can be equal probability, or it may not be equal probability of selection. Okay, so we are coming on the types of probability sampling. Okay, so before coming on the types of probability sampling, there is a very important concept which we call it as sampling frames. Okay, so probability, as you already know that how to calculate the probability, it is nothing but it is favorable number of cases divided by total number of cases. For example, tossing of a coin, probability of getting heads, so favorable. If in a single toss, head can occur only one time when the outcome is head. And total possible outcomes can be head or tail. So it is 1/2. Okay, so we know the total possible outcome. So what is sampling frame? Sampling frame is nothing but it is the list of total possible outcomes. So a list must be available from which the samples can be selected, and this listing of all the study units is called your sampling frame. So if the sampling frame is appropriate, then you can have a good probability sampling technique. But if by anyhow someone is not able to make a good sampling frame, then the probability sampling may not be effective. Often, we cannot make the sampling frame of entire population under the entire sample under the study. So what we can do is that we can take a sub part and then make a sampling frame. For example, if someone wants to conduct a survey in a particular region and want to conduct choose the people, so what they can do is that they can for that particular region, what it can do is that they can have the landline numbers. Yeah, and for that particular regions, and everyone might not have the landline, but majority of people during 10 years ago must be having the landline. So majority of the population is included, but not all the population has been included. Okay. Now in today's world, we can have majority of people who are using, say, mobile phones, smartphones. So majority of people are having smartphone, but not everyone is having a smartphone. Sampling frames are very, very vital. If you have not chosen a good sampling frames, your entire research may suffer. But if you have a good sampling frame, your outcome might be worth studying further. So this is, you can see the square box. So this is the population. Within the population, we are not interested to study the entire population. We have chosen a sampling frame. And from this sampling frame, we are choosing a small subset represented by green image. That is our sample. And the process with which we are choosing it is called your sampling process. And based on the small sample, we are making inference about the population. So now coming on the types of probability sampling, the number one and the most important one is simple random sampling. Simple random sampling, each member of the study population has an equal probability of being selected. There are some examples. One is the lottery method and second one is a random number table method. Lottery method, you already know what you have to do is that you can arrange your all study units in some order, ascending or descending order, and provide them a serial number, fold them in a similar type of a chit, and randomly you can pick one chit out of the total. And whosoever is being selected is included in your sample. So in this way, suppose you are having 100 students in a class and you want to select 10 students. So what we can do, we can make 100 chits, roll numbers ranging from 1 to 100 assigned to each and every student. Randomly, I have chosen and I got 31. So 31 is being selected in my sample. And what is, since I am calling it as a probability sampling, what is the probability that 31 is being selected? It is favorable when only 31 gets selected, that is 1, and total is 100, 1 by 100. So every unit which I am drawing has an equal probability of being selected, that is 1 by 100. If we are doing selection with replacement, that is we are drawing a chit and putting it back. Second method of selection using simple random sampling is using random number table. Okay, suppose you have to select 1,000 individuals out of a population of 10,000. So it is very difficult to make 10,000 chits and 1,000 draws. It will consume a lot of time and may not be feasible also. So what we are doing is that we are taking the help of random number tables. And the random number table is a random assignment of the number. Here, randomly, we can choose any number in a particular, we can choose randomly any row and any column, and randomly we choose it. For example, if we have chosen, say, row 6, and we have chosen the column first and second. So here, so the first selection is 44. roll number 44 is being selected, then we can move vertically or we can move horizontally. So if we are moving vertically, we have first selection as 44, second as 66, third as 36, then 48, 64, like that. So like that, we can choose all the 10 selections. So often these random number tables are computer generated tables, and the selection or the principle behind that is that each and every unit has equal likelihood of being included in our sample. Second one is a systematic sampling. The first unit is selected at random. Subsequently, units are selected in a systematic way. For example, I have to choose 5 patients out of say 50 patients. From 50 patients, I randomly have to choose only 5 patients. So what I can do is that randomly I can choose 1 to 50. I have the listing of all the patients. Randomly, I will choose one patient using SRS. So suppose I have chosen a patient and I got it as a patient with the serial number 10 is being included. Now, I would be at an equal sampling interval. Sampling interval is how it is calculated. It is total sample size, that is capital N. Here it is 50 divided by required sample size, that is small n. In our case, it is 5. So 50 by 5, that is 10. At 10 sampling interval, I will be choosing the another individual. The first one is 10, the another one would be 20, then again another one would be 30, then another would be 40, then 50. Like that, I can choose all the 5 subjects included in our sample. The advantage of systematic sampling is that it is easy to do and often very cheaper also. The disadvantage is that if the first unit which is included in your sample is not a representative of the population, your entire sample may be a biased one. For example, you have chosen let me show you an example for a better understanding. Okay. So here we have shown you that this house is being selected and we have a sampling interval of 2. So after 2 houses, this one is selected. Then after 2 houses, this one is selected. Like that, we are choosing it. Okay. Now, suppose we are adopting this sampling technique for say our vaccination coverage. Okay. And suppose the vaccination coverage vaccination day is generally chosen as a say Monday, but randomly you have chosen a day which you got Wednesday, and you have got a sampling interval of 7. So every time a Wednesday would be being included in your sample, but generally the coverage of the population is maximum occurring on Monday. So you might be getting a sample which may report underestimation of vaccination. So in that way, you might be getting a sample which is not a representative of the population. Now coming on the third sampling technique, which we are calling it as a stratified sampling technique. Here, the population is divided into natural subgroups. Why it is done? Why it is done? Because often the population is very heterogeneous. Okay, suppose you want to assess the average income of the population. Okay, and in that population, 20% population are very elite population. 30% populations are good income people, and rest 50% are very poor people. So what will happen if you have done an equal allocation? Suppose you have chosen 50 from the upper income group and 50% from the lower income group. So on an average, you will be getting an average salary, but that is not a true representative of the population. So what we need to do is that we need to adopt the stratified sampling. Here, the entire population is divided into different strata, such that within the strata, they are homogeneous. For example, all the elite people will be in one strata. All the good income people will be in another strata. All the poor income people will be in the another strata. Now, within the strata, they are homogeneous, but in between elite and good and poor, they are heterogeneous. So like that, we have to do the stratification, and then what we can do is that then we can choose randomly from each data the required sample to be the representative of the population. So stratified sampling technique is the most powerful sampling technique. The disadvantage is that often the stratification cost is very high, and it is difficult to do the stratification also. So this is a pictorial presentation of stratified sampling. You have the population which is heterogeneous. You are making it homogeneous by stratification, and then you are drawing samples from each strata. Okay. Now, coming on another type of a very important sampling, which we are calling it as a cluster sampling technique. Cluster sampling technique is just a reverse of stratified sampling technique. Uh, Often it is easy to study a group of population than individuals. For example, if I want to make a survey of students, different students who are giving exams in different boards. Okay, so it is difficult if you have chosen different students as a study units. So I will be asking the students in which board you are giving your exams. He may say that CBSE, another one might say UP board, someone may say ICC board, like that. But often it is not a very good approach. So instead of that, what we can do is that we can study the schools. How many schools in that area are of CBSE? How many schools in that area are of ICSE? How many schools in that area are of the state board? Like that, we can study a group of population easily than to study the individual subjects. Cluster sampling, as I have suggested, is the reverse of stratified sampling. How clusters are defined? The entire population is divided into different clusters such that within the cluster, they are heterogeneous, and in between they are homogeneous. So we can divide the population into different clusters, and randomly we can choose any one cluster and study the population characteristics. Often it has some specific types. For example, we have 30 cluster sampling techniques and many other cluster sampling techniques which are specialized part of some cluster sampling are being studied or are conducted. Now coming to the non-probability sampling techniques. So basically there are four types of non-probability sampling technique. The first one is quota sampling, then judgmental, convenience, and snowball. Okay. Now quota sampling. What is quota sampling? As the name is suggesting, we have definite quota. For example, if you are doing a stratified sampling, and you have decided that based on the stratified sampling, there are 4 statas. Often the cost of stratification is very high. And what happened at the end, that it is left to the PI or the researcher that, okay, we have made the 4 stata. Now, based on your objective, you can choose how much percentage of sample you want to draw from each stata. So if he is drawing 25% from each 4 samples, then it may be called as the equal allocation of the samples from each data. But often the PI might feel that a particular data is more important. So he may say that from the first data, I would be drawing, say, 40%. The second data, I will be drawing 30%. And the rest 30%, I would be drawing 15 from the other two. So like that, it is left to the judgment of the PI. Okay, often in quota sampling, one more approach is adopted, which is called PPS technique, sample proportion to size. Okay, first data is having a population of say 40%. So what 40% sample would be drawn from first data. Second data population is comprised of 10%. 10% would be drawn from that thing. So here samples are drawn proportion to the size. So that is quota sampling. Second sampling technique, which we are calling it, is a judgmental sampling. As the name is suggesting, judgment. So based on the decision of the researcher or the PI, the sample is being included in the study. For example, someone is doing a study on the etiology of a particular disease. Okay, so he or she might feel that a particular characteristics is very important for me. Say family history of this type of infection. Okay, so the researcher might make a criteria that I will be choosing only that patients in my group who have a family history of this thing. Otherwise, the sample may not be included, will not be included in my population. So if the samples is inclusion or exclusion depends on the judgment of the researcher, then that type of sampling techniques is called judgmental sampling. The third one is convenience sampling, as the name is suggesting, based on the convenience. Okay, so if I have to conduct a sample and I have a limited time frame, for example, for the thesis work, right, we have a limited time frame, and suppose if someone is saying that you have to cover a population which is having a very large geographical region to cover, so it may not be possible to cover the entire population in that fixed time interval. So based on the convenience, the PI or the researcher might say that, okay, you can take the samples from our hospital in which he or she is practicing. Okay. Based on the convenience, the students may choose the sample. Fourth one is snowball sampling technique. Sometimes the diseases are very rare in nature, or the information which you want to obtain has a very less prevalence. Or is following iceberg phenomena. For example, STD, sexually transmitted diseases, people often do not discuss it with them. STDs, we have domestic violence cases, we have HIV. So, no matter what probability sampling technique you adopt, you will not be getting a representative samples. So, in snowball sampling technique, what we are doing is that we are identifying a particular case, and that case is giving lead to another case. For example, if I have to conduct a survey for the sample of HIV patients. So what I will do is that from any HIV counseling center, I will identify one patient and record his data, and will counsel that patient and will ask him where the next sample I can find. So that particular patient will give me information about the next patient. The next patient will give me the information about the another next patient. Like that, my entire snowball is reformed. So like that, I would be getting the required samples and sampling technique. So snowball sampling technique is a very powerful non-probability sampling technique. So this is the gist of all the sampling techniques. So sampling techniques are broadly classified into two groups: probability sampling, non-probability. Within probability, we have four types: simple random sampling, systematic, stratified, cluster. And non-probability, we have four techniques: judgmental, convenience, quota, and snowball sampling techniques. That's all from my friends. Thank you for your kind attention. I hope you enjoyed the video. Thank you, dear friends.